see that? Let me know if you're good on that.
Yeah, I can see it.
Okay. So we have to figure out what x plus 3 means, and unless there's something unusual, it means 3 left. This plus 3, it's the opposite of what you would think it would be.
Yeah.
So one way to do this is to literally move the points. The other option is to make a table. So I'll give you, move points. 2 is to make a table. So if A moves, left 3, 1, 2, 3, there it is. Okay, there's the new point. But then minus y, that means to reflect over the x-axis. It's positive becomes negative. So since it's up here at positive 6, it's going to be down here at negative 6. Does that seem reasonable to you?
Yeah, I'm just so there's a key it's so what it's saying is you literally just take the points that are already given and add 3 and make the y opposite.
Okay, so
you literally just add 3 to x.
Yeah, so that's why I wasn't sure about this. So yeah, so ignore everything I just said. I'll know for now what that means. This is not true in other contexts, but it works out here. So right 3 is 1, 2, 3, and then down there.
Yeah, that's what we have.
Yeah.
That's what the key has.
Yeah, A prime, and then B, right 3, 1, 2, 3, and then flip it. So it's down here, B prime, and then C is right here. So here's your C prime, something like that.
Yeah. Yeah.
Is that reasonable?
Mm-hmm.
Okay.
So the next problem is like the ones that I have I'm a little struggling with. It's the rotations. I really I know what to do, but it's I don't know how to do it on paper.
Well, there's rules for the clockwise and counterclockwise. So counterclockwise is going that direction.
Yeah.
And it's like, for example, C is here. I kind of make this L shape. So if you rotate this L, the L rotates down there. Oh, I'm sorry, about a point. I didn't even notice that. I'm sorry. So it picks a point, -2, 0. Okay, so you almost draw a figure to the point that you're rotating about, and you rotate that 90 degrees, which usually is a little bit easier to see. So if you can imagine this point, this thing literally, it's hard to even, you're going that way 90 degrees. So it's this sort of dash shape. So that C is there.
Okay.
The A, it's kind of the same. It's this L, this hanging L. And when you rotate it, it looks like this, however many up it's going. So let's see, it goes 6. So 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6. So your A prime is there. And then this B, you draw this sort of L again. And then when you push it that way, 90 degrees counterclockwise, this goes up 1 and then left 1, 2, 3, 1, 2, 3. So over here is your B prime. Is that, there's a rule. You could literally, you could literally remember the rules, but I don't think it's very effective to do that.
Yeah, I think I get it.
So we can just focus on rotations. If that would help.
Let's just focus on rotations for now. Everything else seems to be pretty good.
Let me draw something then. So here's the point is arbitrary that you're choosing to rotate around. But let me draw like something like this. So let's say we want to go 90 degrees clockwise.
Okay.
So that's this direction. So you pick your point, and I like to make these L's, and I'm going to go this way with my L. And then I imagine, like, if you push this thing over, this part that's vertical becomes flat, and this part that's horizontal becomes vertical. So there's 5 points up there. So you go 1, 2, 3, 4, 5 there, and then up 1, 2, 3. So this point rotates there. So that's A. That's my A prime. And then same thing, like for this point here, you imagine you draw it L, and you can make it however you want, but it went up. So when you push it 90 degrees, verticals go horizontal. So you go right 1, and then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So it ends up being up there. And this point, you can do the same thing. You can however you comfortable drawing your L's. You can draw an L like that, and then when you push it up, this piece comes here, and then this piece comes up from it.
Yeah, okay, that makes a lot more sense now.
Okay, so there's really only and just to be clear, there's 90 degrees clockwise is the same as 270 degrees counterclockwise. 90 degrees 90 degrees counterclockwise is the same as 270 degrees clockwise. So your instructor might give you one of those. And then 180 degrees clockwise is equal to 180 degrees, counterclockwise. Because and these are the same. Y equals x and y equals minus x. These are sort of related to all this as well.
Yeah. So there's another thing that I had a little trouble with when doing this, and it's the reflect over y equals negative x. Does that mean we just make an x negative?
No, it's let me graph it here. There's a rule for this also. This one I might have to look up because I don't remember. But if it's the line y equals x, you just switch x for y and then y for x. But this one I think has a specific rule. So this line y equals minus x is going through here.
Okay.
And like the one way you could do it is just visualize where the points are. Like this one is there, so this other point goes over here. This B goes this way, so it comes down here where the C is. So that's B prime, and then C prime is up there, and you get something that looks like that.
All right, that makes sense.
So that's one way to do it. There's also rules again, but if you can draw it reasonably well, you'll get it correct most times.
Okay. All right. And then the second page is obviously a little bit harder.
Okay. Do you want me to, when you say second page, you mean the one that says reflect ABC over y equals 2?
Yes.
Okay.
Might not be a little better after this though.
Okay, so let's do them one at a time. Y equals 2. It's good to draw that line. The line is right there. Y equals 2. So when you're reflecting it, I mean, if it's right on the line, it stays there. That's A prime.
Yeah.
B comes up here. That's B prime. And then C prime is up here. So it looks like this. And
yeah.
So when you dilate by a factor of 2 about point A, well, that's really about A prime. That's here. So it's almost like you want to redraw it so you can see what you're doing. But from A prime to B prime, it's a length of 2.
Yeah.
So the factor of 2 means you're going to pull it up 4.
Okay.
So that's A double prime up there.
All right.
This one is a little bit harder to figure because it's
Looks like right 4 up 2 or something.
yeah, 4-2.
So it'd be over 8 up 4.
Yeah, so you have to, yeah, exactly. So you go, and then you get, and then you can see that this attaches on there. C
Yeah.
double prime.
All right, that makes sense. That makes sense.
So the key is to do it in stages.
Yeah.
That's
Like not all at once.
not all at once. All right, I'm gonna pull up the next one here.
Yeah.
Okay, rotate ABC over 90 degrees about point C. So that's critical. Clockwise means you're going that direction.
Mm-hmm.
And you can draw the L's, but the L's are already there. So that like the left L here to get to A,
Mm-hmm.
you're gonna go up 4 and then right 2.
Yeah.
And then to get to B, you're just going up 4. So that's A prime, B prime, and then you just connect it there. So there's your A prime, B prime, C prime.
Mm-hmm.
And then you're going to choose over the line y equals 4. So that's right here. And the only point that's going to change this C, it's just going to go up here to C double prime. The other ones just stay exactly where they're, because they're on, when you're on that line, they don't go anywhere.
Right. So what if, just for example, what if you're to reflect over y equals 3 in this case?
Yeah, good question. So let's actually draw that, and then we can try to answer it. So let's say this is the line that you're reflecting over.
Yeah.
You choose each point. So like, let's just say this is A. I'm 3 units away, so I go up 3 units. B is 1 unit away, but going this way, so it comes onto this side. And then same thing with C. It's 1 unit away, but it comes down here. So it can actually, finish up on itself.
Okay.
Overlap onto itself.
So the whole the whole thing about this like transformations is it's not where it looks like it should be. It's just from where the line is. Like it looks like you should it looks like you should just like from this like flip it over and it should end up in a different place than where it actually is. But then, like just remembering to make sure like to count from the line because or you can make a mistake.
Like if you're thinking about something like where the line is actually separated away from it, then the whole thing does actually flip over like you're thinking.
Like it's like it's just like to make sure that you go from the line, not where like
yeah.
It just I don't know how to explain it. Just make sure you're going from the line though.
Okay, so are we ready to move on to the next ones? To the transformations that would map ABC to XYZ?
Yeah. So I think I have a decent understanding of this, but I'm not 100% sure.
Well, there's many correct options here, and it like depends on what your instructor wants you to do, because you are.
So my instructor, he just says how it doesn't matter how you get there, just if you get there, it'll be right.
Okay. So for sure, like I see that you could say for sure that this is moved, left and right, up and down, but then it's flipped. So whenever you start flipping something, like let's say I flip it here, and then flip it here, at some point you're going to realize you got to rotate to get this.
Mm-hmm.
So like if you rotate it all down that way, if you go counterclockwise 90 degrees, it's going to look, I'm just shortcutting the work here, it's going to look like this.
Yeah, that's what I saw right away was
okay, and then it moves this way and this way to get down into this position. So there's 3 things. Now the order actually doesn't matter, but you might want to say, just for simplicity, that you're going to rotate 90 degrees counterclockwise about C.
Okay, so do we have like can we just say rotate 90 degrees counterclockwise, or do we have to say about C?
Yes, because if you don't say the point you're rotating, it could rotate about A, and it would look like this.
All right. Okay, that makes sense.
Actually, that's not even right. It would look like this around A, and that's weird, but that is correct. Like you could do it around A, and that's why I said there's several of these, because then you're still moving down and right, but
yeah.
So then it's just a matter of, well, C is going down. Point C to get to Z is going down 5. So we say down 5, which is Y minus 5.
Mm-hmm.
And then right 5, which
Yeah,
is
looks about 5.
X plus 5.
Mm-hmm. Okay. Okay, so can I try the so the next one obviously has dilations.
Yes.
So what I see right away is like, I think rotating it 180 degrees. So it looked like, actually no. I think you should flip it over X is 0 or Y is 0. Wait, let me think. That's Y. Yeah, over X is 0. That's the first thing I see. So we can get like the same, get the triangle facing the same way.
You have to get the triangles. You really need to get point B to where point Y is.
Yeah, so flip it across X, flip across.
I would flip it here first. X equals 4, because then I'll get it to look like that.
Oh, I see.
Okay. And then I'm going to move
right,
it.
we're going from ABC to XYZ, not XYZ.
Yes.
My bad. Yeah, I see that. Now we have the shape facing the same way.
Right. So then what do you do from there? You can move it. You could dilate it. You could dilate it and then move it, or you could move it and then dilate it. It doesn't really matter.
I think move it and dilate it, because then I can see what I have to dilate about better.
Okay.
I think. So I guess you'd 1, 2. Let me pull up. So I'd move it 1, 2, 3, 4, 5 right, and
Okay.
up 1, 2, 3, 4, 5. Right 5, up 5.
Yeah.
I think, yeah, just to where it is. And then I can't necessarily tell what it's dilated. I think it's, yeah, and then I dilate it by 2.
Yes. So there's I think 4 things there. 1, 2, 3, 4, and you set them all. You're gonna flip over X equals minus 4. You're gonna go right 5. That's X plus 5.
Mm-hmm.
You're gonna go up 5, which is Y plus 5. You're gonna dilate by a factor of 2, but there's one little piece there. You have to say around point Y, or I guess B.
Okay.
If you don't say the point that you're dilating about, it'll be unclear.
Okay. All right. And then the next part was just like, it's like part of the review, because we need to we can move on to the next problems, but I just don't know how important they're going to be. We just got introduced to them.
You talking about the capital K?
Yeah.
I mean, these lead you into transformations with functions, and I mean they're probably useful, but you'll never do this. But the idea is like what and this is hard to do unless you're really good at drawing. But I mean, here's a K. So if you shrink it vertically, you're pushing everything down.
Mhm.
So I guess it would look, if you do it by a half, it goes down to something like that, or a stretch. So you can go this way as a stretch, and then this way as a shrink.
I was looking more towards the identify a letter in the alphabet.
Okay, which
But I guess it needs to. I guess it needs to have all of these, and it has like a little picture of the alphabet, just so we can like. So those are probably perfect drawings, or what he wants us to go off of.
so something with a one-fold symmetry, but not a, or is it like one each, or is it all of them?
I think it's just one for each.
Okay. So one-fold symmetry means either x-axis or y-axis, so like either vertical or horizontal.
Mm-hmm.
And I mean, you're probably gonna have some that work with multiple ones. Like it would be unusual for it to only have like it would be unusual to only have one-fold symmetry.
Mm-hmm. I think the whole idea is like, okay, we could choose the uppercase I for one-fold symmetry, and it would work.
But it also is two-fold symmetry because you can go horizontal or vertical for it. Like if you cut I this way, it's the same as cutting. I mean, it is cutting this way. You get both horizontal and vertical. Does that?
Yeah, it makes sense. But just
So,
what?
so like B is an example of if you cut it this way,
Yeah.
it's great. It works. But if you go the other way, this doesn't look the same on both sides.
I was gonna say W works too.
W works as well. Yeah, that way, but not the other way.
Wait, maybe W does work.
Not for oh, this is one fold rotational. I don't know what that is. One fold rotational.
So if you rotate it, what? If you were to rotate it, then it'd be the same.
Well, yeah, I'm not sure. Look at
All right,
the
okay.
letters.
Well,
Maybe S looks pretty promising because it doesn't work there and that, but if you rotate it around that line.
yeah. I remember. We were doing that in class on Friday. We were trying to figure this one out. So I'm pretty sure it is S. At least that's what my group came up with. And we were pretty sure it was right.
That sounds pretty reasonable.
Okay. All right. So I guess we do like we're down to C.
Okay. Rotation symmetry. So S kind of works for that. Anything that you can rotate 180 degrees and get back. I mean, the one we're not doing that most of these have is O. I mean, O works for everything.
O works for everything.
And your instructor probably should have excluded it.
Did it actually? I mean, it works for a lot of them.
Yeah. This 90-degree rotation symmetry, O works again for that. I mean, it depends on how you draw it, but it's usually that's an O.
Would I work for that as well?
Well, if you go 90 degrees, it works for 180, but if you go 90, it doesn't look.
It doesn't look right. Is there anything else that does work for 90?
X might work, depending on how it's drawn.
Yeah. How else do you draw X? I've only drawn X one way my entire life.
Well, it really has more vertical than it's more vertical than it is horizontal. So if you rotated it, it would look more like that. Which maybe it's still an X, but it's ugly
deformed. X. Okay, and then rotational symmetry, but no lines of symmetry.
Yeah, let's see. Yeah, that means you got to rotate it like 180 degrees and get back to where you started. N looks like it's a good choice for that, because if you rotate it 180 degrees, you get back to an N, but it doesn't work that way, or horizontal or
I
vertical.
thought it worked if you cut it straight down the middle and you flipped one side. I think it'd still be the same, but I don't know if that's what they're asking.
Well, rotational symmetry is either going 180 degrees, 90 degrees.
Okay, so yeah, I think N would work for that then.
Yeah. Which letters will have vertical reflection where the letter remains the same, but horizontal reflection will change the letters? So since it's asking for letters, you have to go through them all now. So like B is a good one.
Yeah.
B works. C works. D works. E works. And then I guess K works. So basically does the, well, if L works, then the top and the bottom are the same.
I said O. O as in orange.
Well, but it says, but a horizontal reflection will change the letters. So O is bad because even though the top and bottom looks the same, the cut the other way doesn't work.
Yeah.
So I think those are it. But now we can look at some of the ones where a horizontal reflection, where the lever remains the same, but the vertical will change it. So this is where the left half and the right half look the same. So A is good. And then but I has a I.
Oh yeah,
yeah. How about M?
Yes.
Okay. Left and the right are the same.
T.
Yep, I missed T. VW and Y.
Yeah.
So for which letters is the uppercase a vertical stretch of the lowercase? You're really looking at, does the lowercase look just like it, except it's not pulled out? So like
C.
C looks good.
M. N.
So they're kind of have curves to them, so I would say not.
Okay.
He's sort of interesting. It maybe does, but it's also a translation.
Yeah.
Probably S is good. U's got a little tail. V looks good. W looks good.
Good.
X looks good.
Looks good, yeah. C. And then these are just some random questions, just like on the other problems. So let's say we have like a triangle ABC, which we were using before.
Okay.
Let's just draw ABC. And it's like, let's say it's in it's in quadrant 2, and we have another XYZ that's in quadrant 4.
Okay.
Like how would that like, so let's say we wanted to wait, what's the
Is this a specific problem that I should look at, or are you just making?
No, I'm just making this up as I go. I'm trying to figure out how to explain it. It's a little difficult.
If you have something there and something here, you went right and then down. That's pretty.
But I'm saying let's say we we dilate by another point. Let's say 1, 1.
So if you're dilating about that point.
Yeah. So.
Okay. So
how does that work?
Well, let me choose something nice here. So this is 2 away. Let's use a K equals 2 on this. So you're 2 away. So now you're gonna go 4 away. So that's, if the A is there, A prime is there. This point is 2 plus, it's 5 away. So K equals 2, you're gonna go 10 away.
Okay.
So 1, 2, 3, 4, 5. So that's B prime. And then this one, you can do the same thing we talked about. It goes, 2 and then 3, so that's 4, and then
6.
Then 6. So that's C prime. So it gets bigger and it gets further away when you dilate like that.
Okay. All right, that makes more sense. And then the other one is, let's say we're moving from a point, like well, let's just ABC again, and then we're trying to move from, let's 2,3. Like,
I guess I need an example. Here's 2, 3.
Hold on, I gotta think about this. I had an idea in my head, but it doesn't make sense now. Never mind. It doesn't make sense. It's
Okay.
not possible.
Okay, where do we go from here? What would be next to work on?
I guess just more of those.
Okay, well, we should do some more rotations. Do you have graph paper available?
Not right next to me. No, I can get some.
I mean, I would, but I mean, I'll try and draw it as best I can. But it's
that's fine.
You know, I'm not the best at that. But these are 1x1s grids. This is A, B, C, and we're going to go counterclockwise 90 degrees about point A.
Okay. Let me get some graph paper.
Okay.
Okay, I got some graph paper. Let me draw this.
Yeah, give it a try, and then I'll put the answer down after you've done it, and you can check your work.
Okay.
I will let you know how this goes.
All right, I got the triangle drawn. And we're about point A. A, B, C. Okay. So it's just A prime.
All right, Zane, how you doing on that?
I think I got it.
All right, so here's B prime is up here, and then C prime is the only one that's kind of a bit of a work here. 1, 2, 3, 4. 1, 2, 3, 4. There's your C prime. So something like that. 1, 2, 3, 4, 5. Oh, I got 5. Sorry, it's right there.
I don't think. Oh, hold on, I screwed up B. So yeah, I have the same thing.
Okay, great. Let's try another one here that's a little more difficult. Because these clockwise ones are the ones that are really trying to get you ready for your examination here. So let's see. So we got to still do this one, and this is A, B, C. We'll go 90 degrees clockwise around the point -2, 2.
Okay.
So the key here is to actually draw that point. And then clockwise means you're going that direction. So if it's horizontal, it becomes vertical. So there's your B prime.
Okay.
If you're coming straight up here like this, if you push it clockwise, it goes the whole thing has to swing. So this actually, clockwise can also be that direction because it's in a circle.
Yeah.
So this piece actually swings up to the left here. So if it's 3 away, it goes 3 away. That's your A prime, and then your C. You make another kind of L here, and then that you can imagine just sort of this swinging down, like that. So we got it going right 1, and then down horizontal becomes vertical. So you go down for 1, 2, 3, 4. So there's our points there.
Okay. Yeah, I think that makes sense.
Yeah, these are yeah. So let's see here. I don't know. Do you have other stuff you want to work on? Or is this it?
No, this is it.
Okay. All right. So here's A, B, C. I want you to go clockwise 90 degrees about the point -1, -1. So that's the point here.
Okay. Okay. All right. So. All right. I got my triangle drawn.
Okay.
Okay, now plot -1, -1. All right. So. And then we're going to do clockwise. So. Okay, so this is A prime. This is B prime. Wait, 1, 2, 3, 4, 1. That makes no sense. All right, I got it.
You're able to replicate this? All right. Let's do another one here. We'll go the other direction now. So we'll do counterclockwise. All right, so we're going to go A, B, C, go counterclockwise 90 degrees about point A.
Sit. Here you go. Sit.
All right. Okay. We're doing this about point A, correct?
About A, that was similar to one of the ones that you gave me. So A just stays by itself.
Mm-hmm.
We're going that direction, but it could be like that or like that. Maybe it's even good to draw those arrows to kind of get a feel for where the lines are go. Like this line from A to C is going to go that way. B to C is going to go more that way. That one's going more that way, kind of thing.
Okay. Wait, so if it's about point A, we just...
You still want to draw your L's. I mean, it doesn't matter whether you go like this kind of L or the one that goes this way. Either one will work. They'll get you the same place.
Mm-hmm.
So there's your C prime. Then your B, you're going out. Let's see, somewhere there. So look right now, it's one more. There's your B prime. Now it's one more. Wow, yeah, there it is right there.
So that should be C prime. That should be B prime, and this is A prime. Yeah, I got it.
Okay. Do you want to use 5 minutes for question of the week or something else?
That sounds good.
All right, let me grab it. I don't even know what it is.
I can pull it up too. It's tutoring by Matthew. Okay, got it. I was like trying to meet with you one week, and I look up math by Matthew, and it's like all teacher stuff, and I'm like, well, this is awkward.
I had some brand changes, and I appreciate you texting me. So,
do you do teachers now too? Do you?
I'm trying to. I'm moving in that direction. So it's a slow process.
And it's the question of the week now.
Yeah, so I'm gonna start launching some videos to go along with it, and but if you ever want a book of questions, I'd be happy to give you one to work on.
All right.
Okay, so at a recent annual meeting, a waste company reviewed their policy on radioactive material disposal. Karina, an engineer who works at the company, found that the ratio of radioactive material to non-radioactive material, Z, is approximated by the formula Z equals B times the quantity 3 to the power of minus T over 19, where B is the ratio of radioactive material to non-radioactive material initially present, and T is the number of years since the year 2008. If B equals 1, how much does the ratio Z decrease from the year 2046 to 2084? So in short, you have to calculate Z for the year 2046 and Z for the year 2084. The thing that could be challenging here, and this is not a calculator problem, is you may not look real closely and realize that T is actually the number of years since 2008. So for 2046, T is actually 38. And for 2084, I'll make this one a little bit clearer. It's 2084 minus 2008 over, I'm sorry, it's T is equal to 2084 minus 2008, and that is 76.
Yeah.
Okay, so for this calculation, it's Z equals B, but B is 1, so it's not important. 3 to the minus 38 over 19, which is really 3 to the minus 2 power. Is that just nicely reduces?
Yeah.
This is 1/9.
Okay.
This is 3 to the minus 76 over 19, which is 3 to the minus 4 power, which is 1 over 3 to the 4th, which is 1 over 81. Since we want the decrease, we're subtracting. So that's 1/9 minus 1 over 81. You want to convert the one on the left to a denominator of 81. So you multiply the top and bottom by 9. 9 over 81 minus 1 over 81.
8 over 81.
8 over 81. So if you can do a problem like this in under, around 80 seconds or less, you're in good shape for the SAT, ACT.
No, I was not ready for that.
All right. Well, thank you so much, Zane. I'll send you out the notes and the screen recording here shortly. And
Thank you.
see you next time.
Yep. Thank you.
Bye now.